Hello, welcome to this Griffin video. This is going to be the first in a series of videos where I take an in-depth look at the Griffin optimizer. What is the optimizer, what is it doing, and how can we best utilize it to our maximum advantage? So the optimizer is this little component here. I've created one, and the optimizer is essentially a tool to allow you to explore the possible inputs to a model in search of the best output from the model. Now, Griffin has various different types of models available. Quite often we'll be using a neural network model, but there's no requirement that the model be a neural network. In the model selection box here is going to be pretty much any model you have built on the system. It could be a custom model that you define yourself. It could be some sort of polynomial fit. It could be many different things. As far as the optimizer is concerned, it doesn't matter what the model is. The optimizer is simply sending inputs to the model to test and get back the predicted output value. I have a diagram here to help us understand that. So the particle swarm optimizer basically creates a bunch of different particles. We have this PSO Test Tool to help visualize this process. To access this tool, you go to the Advanced Settings, PSO Test Tool. So I have it set up here with a few different high and low spots. The optimizer is a minimizing optimizer, so it's going to search for low spots. This is a high spot. These are medium spots, and the dark blue is the lowest spots on the map. So if we have this test tool open and we click run, we can set up all of our swarm parameters here, similar to how they are in this setting, in this page of the optimizer settings. So we'll click run, and now I have greatly reduced our default velocity limit. Our default velocity limit is 0.4, but if we run it like this, you see things are going to move pretty quickly. You can't really tell what's going on. So I'm going to reduce this velocity. You're not going to want to do this in practice because this can mess with the quality of solution you're going to get, but for this purpose it's fine. So this is basically a visualization of what the particle swarm optimizer is doing behind the scenes. I'm going to pause it here and explain. Each of these dots is a particle. Now this is a 2D solution space. We basically have the x coordinate and the y coordinate. Those are our only two inputs, and our model is essentially the value in height of this map. So this is a high height, this is a low height, the green is a medium height. The swarm is comprised of a bunch of these little particles. Each particle is initialized, and I can do this here and stop it closer to the beginning. So each particle is initialized at a random location and with a random velocity. Now in a practical problem, it's not going to be a 2D solution space most likely. It's going to be something of a lot higher dimension, maybe 5 degrees of freedom, maybe 10, maybe 30, maybe 100 or 200. The particles are assigned a value in each degree of freedom and a velocity, meaning a rate of change of that degree of freedom. And what the particles are going to do is basically gravitate toward the best solution that has been discovered by any particle in the swarm, and to a lesser extent they're going to gravitate toward the best solution that that individual particle has achieved. Now I can change these settings and show you the effect. So this global best learning factor, this is essentially the magnetism toward the global best. If I take that down to 0, every particle is basically just going to hang out where it started off. Let's add a little bit in. So now they're being drawn toward the global best, but not enough to pull some of them away from their local minima. If I bring this back up to our default value, you're going to see all the particles moving all the way toward the center. So this particle swarm optimizer test tool can help you visualize what's going on behind the scenes with our particle swarm optimizer. This graphic here also explains it. So it's important to understand, as I noted in the beginning, that the model is completely separate from the optimizer. The optimizer controls the swarm, and all it uses the model for is to get a predicted output value for a given set of inputs represented by a particular particle in the swarm. The model gives us predicted outputs, and then we plug those into our fitness calculation. Our fitness calculation is fed into the swarm, and the cycle continues. So this has been a short introduction to the concept of a particle swarm optimizer. And in the next video, I'll go through the options in the optimizer in depth and show you what they all do.